Hello everybody. Today we're going to study new chapter, which are DC circuit analysis of RLC circuit. Previous chapter we have studied RL and RC circuit. Now we study RLC circuit on DC condition. The RLC circuit is called a what? Second order circuit. Why it called second order? Second order because it comprises of two storage elements. And two storage element, where this called storage element, it can be what? L and C. This storage element, capacitor or inductor. If got two capacitor, two inductor, also called RLC. This is series RLC circuit. Got two and this storage element, so it's called second order series RLC. This is series. This is parallel. So two storage element L and C connect in parallel. This is called parallel RLC circuit. Where this one series, this is voltage source, parallel, this one is the current source. Next, for this case, two inductor element, consider two only inductor, also called a second order. But this is RL, but second order. This is RL circuit, but it's second order RL circuit. This one. Then this one capacitor. That is two capacitor only. This called RC circuit, but it's second order. Okay, but second order. The RLC circuit has three modes of operation during free running mode, which depend on the right combination value of R, L, and C. They are underdamped, critically damped, and overdamped. Three RLC solution. The solution for this RLC, they can be three: underdamped, critically damped, and overdamped mode. For a series RLC, here series RLC, this one, CRLC, this CRLC, we use what? Kirchhoff current law, Kirchhoff voltage law. Kirchhoff voltage law and Kirchhoff current law, we form the loop I. This IR plus this voltage plus what? IR, this voltage, and this voltage. Add up together, we got IR, voltage drop across resistor, voltage across inductor, voltage across capacitor, then equal to 0. Equals to 0. This loop. At this part, this loop is 0. No voltage supply. So VC is given by this one, capacitor. Then VL is given by this one, LDIDT. And we study in previous chapter. So substitute this one to here, we got this equation. This is called differentiating this called differential integral equation. It got differentiation and integral. So in order to solve this one, we need to eliminate the what? Integral. We need to eliminate this integral. We eliminate the integral, we differentiate this one more time to become a second order differential equation. We want to eliminate this one integral, we differentiate this one more time. Differentiate this one, we erase, we got this one. The all differential is the second order. This second order. So in order to solve this circuit, we need to know the initial value for I and its first derivative. Means that we need to know I. This is I, dIdt. Solve I. We need to solve I for what? I initial value of I0 at time 0 is set is 0. I0 at time 0 is 0. Then also the initial value and its first derivative, its first derivative is V0 equal to minus L dIdt. So it's di0 dt is minus V0 over L. Erase it in I0. The first derivative of I0 is di0 dt equal to minus V0 over dL. So you need to know I0 and this one in order to solve this one. Okay? So This one, if we change to Laplace transform, change this one to Laplace transform, we get this one. S square RLS plus 1 over LC. This no at what? Characteristic equation. Characteristic equation. Then this one have two root. Quadratic is quadratic order 2 ma. It's order 2. So it's got two solutions. So two solutions is this one. You solve this one. You see quadratic equation. You solve this one, you get this one. Root 1, root 2. This root 1 and root 2. S1, S2. Then or you can write in terms of alpha. Alpha plus the enter this one. Alpha square minus omega square. Where alpha is equal to here, then omega naught is equal to this one. This one plus 1 connect to here S1, then S2 here. Okay? Then solution for this one. Solution for equation solution to this one. From this one, we will find the solution for this one. The solution for this one is what? The solution for this one is equals to IT. Equal to here. This one is I. To find this one is I ma. We form I. I is in terms of I or second order differential second order equation. Then we find the characteristic equation. Then we solve for the root S1, S2, S1, S2. Then the solution to this equation, this equation, this equation, solution to this equation. General solution to this equation is put to here A1 ES1T plus A2 ES2T. So to know the value of A1 and A2, one need to apply the initial condition of the circuit. To know A1 and A2, we need to know these two initial conditions. This one, I0 at t equal to 0 and first derivative of initial is minus V0 over L. These two. Then S1, S2 is given by this one. S1, S2. Given by this one. Then substitute to here, we get the general equation. There are three possible solutions. This possible solution, if what? If alpha greater than omega naught means S1 and S2 are two real number. S1, S2 are two real number means that we have overdamped case. You got different equation. If alpha equal to omega naught, S1, S2 are equal, we have critically damped case. Then if alpha less than omega naught means S1, S2 are two complex number, we have underdamped case. You know, alpha and omega depend on S1, S2. The alpha here and omega naught. These two conditions, they got three conditions, three solutions depend on this condition. First, we go to overdamped case. Overdamped. Go to overdamped case first. Overdamped means that what? Alpha greater than omega naught. Means that alpha R over 2L square minus greater than 1 over LC. Means that alpha, this alpha greater than this one. Alpha greater than this square root, take to this side, we get this one. So, for this overdamped condition, if this solution meet, we have the what? Solution is given by, the general solution is given by this one, overdamped. The general solution is given by this one, IT A1 E S1 S2T. This solution, if in exam, I didn't give. You must remember. Okay? So, how to find this one? We do an example. This example, we will do this example in full lecture. Next, second case, critically damped condition. Alpha equal to omega naught. Critical damped condition is alpha equal to omega naught, means that this one is this one. Alpha greater than equal to omega naught equal to S1, S2 are equal. We have critically damped case. Critically damped case. These two are equal. Means S1, S2 are equal. Two roots are equal. Means that the general solution is IT A1T plus A2E omega alpha T. Means alpha is this one. S1 A1 A2. Okay, alpha is equal to minus S1. Is this S1 S2 minus alpha equal to minus R over 2L. Okay, critically damped. Then general solution is this one. See, critically damped condition, the general solution is this one. In exam didn't give. In overdamped case, general solution is what? Overdamped case, general solution is this one. See, not they are different. Different equations depend on what? These two depend on what? On this value, these three value. These three value depend on this one. Okay? Then we will do the exercise in lecture. We do the example in lecture. The underdamped condition with alpha less than omega naught. Means this one less than. So it's underdamped. Means that what? The two roots are what? The two roots are complex. If alpha, if this one r over 2l bracket square less than 1 over LC, mean this condition, we got what? Two complex terms, whereby root of the differential equation are complex terms. Mean complex means that this one complex, like this one. This one, S1 and S2 are complex. Got J plus J minus J. So, why we got one damping frequency? So, compare number. So, the answer IT is given by this one. E minus alpha T A1 E J omega D plus minus J omega D. This is the one. Alpha is this one. Alpha is this one. Omega D is this one. This one. Omega D is this one. Okay? Or this form, you can rephrase in this form also. This one is polar form. This polar one, it become in trigonometry form is this one. Okay? It's the form this one. These two equations, only different. This one is exponential form. This one is trigonometry form. So we will cover this one in lecture. This one is series RLC. This one is for series RLC, figure 7.2. Series RLC, series RLC, like this, series RLC, series. Now we want to go to parallel RLC circuit, second order. Means that current source, it got RLC connected in parallel. Same, it got three conditions also. Underdamped, overdamped, and critically damped. Same. So we use what? Kirchhoff current law. These three branch, this branch. This I plus this I is V, this voltage is V over R. Then this I is C by dV dt. So I inductor, I2 inductor is this one. Then V over R, this C over R. Then this you got integral and differentiation. So when we eliminate this one, we differentiate one more time. We get this one in terms of V. Second order differential equation. Then the solution to differentiate is V. This one is V. Then ES1T plus A2 ES2T. The S2 S1 is the root. See now is the root. So the characteristic equation is what? S square plus 2 alpha S plus omega naught square equal to 0. See now? 2 alpha S. This one we change to this one. Where S1 is what? This solution S1 is what? S1 is this one minus is this one. S2 is this one, 2 root. Second order got 2 root. The alpha is 1 over 2 RC. Omega naught is 1 over square root LC. Remember this is series RLC. Parallel RLC, not series, parallel RLC. So 2 root. One is overdamped. Is this one. Where 2 S1 S2 are real number. Where overdamped 2 error is this general solution. Then critically damped case is S1 S2 are equal. Omega naught critically damped. Then VT is this one. Given by general solution. Remember this one. These three. Underdamped S1 S2 are complex. See not complex is this form. Complex form. Under dam is complex. Two roots are complex number. So in order to find A1, A2 in each case, we can A1, A2 we need to determine from initial condition where V0 and what? dV, D0, dt. Okay? Just now that one is dI not I0 and dI not dt. So dV0 is what? Is this one. dV0 is this one, dV0 is this one. Then dV dt0 is what? Is this one. Is this one. Is this one. Okay? Is this one. Then we will do the what? The exercise in. We'll do the exercise in lecture. Case 1 is what? This other case is this is over dam. Over dam. Then case 2 is what? Case 2 is what? Is critically dam. Then case 3 is what? Under dam. After that, we will do what? We will do the tutorial. See tutorial. After that, we will do the tutorial. This tutorial, okay? A few questions of the tutorial we will do. So, thank you, class.